Hello everyone. Today we will look into STM32CubeIDE and test a small application. STM32IDE is available to download for free from ST site. Let me show you. So just you can type in the Google STM32CubeIDE and just enter. So the first link will take you to STM32CubeIDE page, and here you will get the option to download it. So you can get the latest version or you can select a version from the drop down menu beside it. So I would recommend you to go with 1.16, the latest version. And you will need uh, account at st.com when you will accept it. So here you will have to accept the license and you can get it. Okay, so you can download as a guest or you can create a ST account. So it's all up to you. So as I already have it, so I don't need to download it. Let's see how the launcher is for the STM32CubeIDE. So I have installed it on my system and it is very simple to install. You don't need to configure anything. And when you start the launcher, it will give you the workspace directory to be selected. So I will be selecting, I have created my own workspace here, like in a different type. The default would be workspace 1.16.1. And here you can see all the recent workspaces that you would be working. Okay, you can browse here and select your path of the workspace. Then we can click on launch and it will just launch the STM32 ID. Then we have this is the perspective window that is the Explorer. So here we can see the Explorer. Then here we can see the different menus and options that we will be using it in the subsequent videos. Here you see the build targets and outline of the code that will be visible. Then other tabs like problems or console, then here build analyzer, stack analyzer. And if you don't see some of the options that I am seeing or any of the options that you want, you can go to window, then go to show view, and here you can select from bunch of options that you want. Okay, there are many other options available. So it all depends on your requirement. Now coming to the important things, first we will go to help, and like I said, we are using ST microcontrollers. So here you need to download the embedded software packages. So I'm using STM32Z0 series. So I will be going down here and I have kept it downloaded for the STM32G0 series. Similarly, if you are working on any other microcontroller, you can download the package for the respective controllers, F4 series or any of the controller, F0 series. So these are the available, and you can explore other options also that ST provides here. And the ST gives updates, so you can keep it updated as well. Or if you are working on an older project, you can keep the older firmware packages as well. So now we will see like how we have to create a project. So for creating a project, you can click over here, create a new STM32 project, or you can go to File, New, and here select the STM32 project. It will initialize the STM32 target selector. And once it is initialized, you will see a window that where you can select the microcontroller or microprocessor, or here you can select the board selector. As I am using a Nucleo board, so I can select my G070RB. Okay, it's G070. So this is the Nucleo board that I will be using. And here you can see you can get the document and resources related to the board or data set you can also download. So like I've clicked and it downloaded for me the data set. So it is a general data set. From here Like if you see for your G070, I think it should be here somewhere. Okay, so G070 is UM2324. You can click over here. So this is about the board, not about the microcontroller we will be using. This is about the Nucleo board. Similarly, if you are using Discovery board, it will be having its own document. Okay, now coming to the STM32 ID. If you want to select or if you want to read the reference manual or the data sheet. So here if you come and then select the microcontroller, like I am selecting my 70RB, and it is 128 KB flash, 36 KB RAM and 59 IO. One first option I select. And when you come to docs and resources, then here if you come down, so here you will see the reference manual for the microcontroller of the board, and you can read the details about your microcontroller. Okay, and then you will see other thing that is called as data sheet. Okay, so for data sheet you can read it over here, and it is locally downloaded. You can copy from the user's STM32 Cube folder to any other path. You- and also you can, I will be providing like the document for this particular controller over the GitHub, and you can download it from there. Okay, so this is the data set, and this is a very short document, whereas the reference manual you can see that it is 1,000 page almost a document. So reference manual contains all the peripherals that is connected to the to our microcontroller, and also it shows how the memory and bus architecture is there. Okay, whereas in the data sheet you can see like all the diagrams relate basically the foremost thing is the block diagram, that on which bus which of the peripherals are connected. Like there is one IO port on which can see that GPIOs are hanging. Here we have AHB port, AHB bus actually, where we can see all the other peripherals like timers or ADC, SPI, UART, everything is hanging over here. So like that, we have to analyze both the documents and then we can proceed further. So this was the basic thing that I wanted to show you. And after that, like I am using for now Nucleo board. So I will be selecting this Nucleo board from here and then clicking next. So here you see the project creation window. Here what I will be doing is create a Blinky project, that is a small test project only to demonstrate, and let all the configurations be as default. We will click next and see. So here you can select the different firmware packages. Like if you are working on an older firmware package, then you can select it. And I will be copying only the necessary library files for now. Then finish it and initialize all the peripherals with their default mode. Here you will see the pinout view, that is like microcontroller pins which are visible. And since we are using Nucleo board, you can see that here we have the default pins configured already. So like for at pin A on pin A5, we have green LED that is marked here LED green. Then we have USART on PA2 and PA3. Also, we have RCC oscillators over here. You can enable different pins by clicking on it, and then you can select it as GPIO input or like GPIO output, or if you want it to be in ADC channel mode or USART mode. So different things you can select from here. Then here comes the configuration of the pins. Okay, like if I select it as a USART 3 transmission. Okay, so it is showing yellow because it is conflicting with some other modes. Okay, so if you come over here in the connectivity. So user tree is not enabled for now. That's why it is showing it is conflicting there. So as soon as I select it as a asynchronous mode, that is UART, see it will be configured as a UART mode. Okay, so similarly, you can configure everything from here and you can select whichever pin is required as per your project. For now, I am disabling it. Then second thing is the clock configuration. So every controller has its own clock configurations that we will be seeing in the subsequent videos in the data sheet. So the default high speed internal clock is there that is of 16 megahertz. And for G070, we can take it up to 64 megahertz. Okay, so if I select here 64 megahertz like that and press enter, it will ask you to configure all the other sources. So on clicking OK, you will see that all these 16 megahertz clock sources will change to 64 megahertz. It takes some time to calculate all the data and it will do it. On completing, you can see that system clock is changed to 64 megahertz. And here you can see that there are different clock sources. So this is low speed external, high speed internal, external, PLL clock, and LSI clock. So whatever is your requirement, you can select it from here. Okay. So in the now coming to project manager tab, here you will see your project name. Like since we have already set it earlier, we don't need to rename it, or it won't allow you to rename it. And we are we have to generate the code from here. So in the code generator tab, you can change different settings and check according to your needs. Then on pressing Control plus S, so it will ask you to generate the code. So you can select yes, and we it will switch to C++ perspective. So currently it was pinout view mode. Now it will go to C++ perspective. Select yes, and after selecting that, you see that the perspective window has changed to your coding view. From here, you can see that outline is given. That time I showed it was empty. In here, we have the different functions, or we can say that whatever we are writing. So it is the overview. So it is including the main.h file from here. Then STM32 HL, we have included. Let's change it. So here we have included the main.h. Okay. So similarly, we have in the main.h, if we visit, here we have included our HAL file. Okay, so HAL is hardware abstraction layer that is available, uh, that is made available by the company itself that is producing the controller. Like STM32, we have different HAL. For Texas Instruments, we will have different. For NXP, we will be having a different uh, HAL files. Okay, so coming to main.c, here you will see all the function prototypes, and you will see that user code prompts are given, means comments are given. So for default application that is created by the STM32, you need to create, you need to code between those comment sections. So here we will come into while one, and here we will write a small HAL function. So HAL underscore GPIO, and we will toggle the pin. So which pin and which port? So since we have configured our LED on PA5, we will be selecting GPIO A, and we will be naming it LED green pin. That is already named in our IOC file or device configuration file. Or if you don't, if you have not named it properly, you can simply rename, you can use it like GPIO underscore pin underscore 5. Both will take you to the same thing. Okay. And then we will add a small delay, HAL underscore delay, and of a 1 second. So here HAL takes delay in millisecond. That's why I have given 1000, and then end it. Okay. So to build the project, you can either press here the hammer button, or you can right click it and go to build project. So it will build the file and it will generate your executable file here. Okay. If you are wondering how I am able to write this part of the HAL library, all the HAL functions, you can go to Google and you can search it. What are the HAL functions available for your microcontroller? Like I am using G070 series, so I can search it G070, or you can directly search STM32Z0 HAL library documentation. Here, if you come, you will see that this PDF consists of libraries related to HAL and low level drivers. Okay, if you want to use HAL, you are free to use it. Or if you want to go bare metal, if you want to go some operating system, RTOS or any other thing, you can go with those options as well. You can read the document according to your need. You can get the functions from here. Then coming to our STM32CubeIDE, since we have built the project and it is showing no error over here, we can connect our board and okay, so it is connected. Now we can see to run the project or to debug the project. If you are facing some problems, then you can go into debug perspective, or if you want to directly run the application, then you can go to the run option. And I will be discussing more detail about the debug perspective. So now let's run the Blinky project. It will ask you to launch the configuration. By default, we will be using the debug configuration. We are just testing it. So debug configurations we will be running. Once you see that download is verified successfully, you will see on your board that the green LED that we have configured over here, it is toggling correctly with a delay of 1 second. That is a small demo of the Cube ID. Tomorrow onwards, we will see about the debug perspectives that we have in our STM32 Cube ID, how we test if we face some other problems as well. And I will continue tomorrow. Thank you all. Happy coding.